This is question 2 from paper 1 of the 2019 TMUA exam.
In this question, we're asked to consider the expression x squared plus kx plus 2x plus 1 minus 2k, where k is some real constant. And then we're asked, for what values of k is this expression positive for all x? And we're given the following 8 possible options for values of k for this condition to hold. So the first thing to do is to look at this function and see if we know anything about the graph. Do we know roughly what it looks like? Now, k varies and will move the graph all around, etc. But the one thing we can see is that before the x squared we have a coefficient of 1, or more importantly, we have a positive coefficient. So we know that we're going to have a U-shaped quadratic. Dependent on the value of k, we know it could be up here, or it could be down here, or up here, etc. But the fact that we know it's U-shaped lets us make progress on this. So how do we make progress? Well, we see that when we have our function as always positive, this is exactly when our function in a scenario, say like this. And this is exactly when our quadratic graph has no roots, so it's never 0. And we have a very useful thing we can look at when we're trying to work out if a quadratic has any roots, and that is the discriminant.
So we want our quadratic to have no roots, which means we need to look at the discriminant. So we're looking at b squared minus 4ac. Now looking at this and collecting together the terms, see a is 1, that's nice because it's the only x squared here. B is k plus 2 because we've got plus kx and plus 2x. And c is clearly this 1 minus 2k. So what do we need? We need no roots, so we need the discriminant to be less than 0. So let's do the logical thing. Let's work out what b squared minus 4ac is with our a, b and c here. So we have k plus 2 all squared minus 4 times, 1 times the 1 minus 2k. Less than 0. Let's expand. Hope some things cancel. So k squared plus 4k plus 4, then minus 4 plus 8k is less than 0. And you'll probably see that the 4 and minus 4 cancel, which is very nice because we get this relatively simple expression compared to this. So we've got something that looks pretty dealable with here. And indeed it is. We can factorise a k out to get k lots of k plus 12 less than 0. And then just to double check that we pick the right range, let's draw a quick little graph of this. So we know it looks like this with zeros at minus 12 and 0. So we can quite clearly see that we pick k between minus 12 and 0 to get this condition of less than 0. So we know this is the criterion we're looking for, and if we look back at the options we're given, it's reassuring because we see it matches A, and so we know our answer is A.